In this problem, a galvanometer has a coil resistance of 100 ohms and requires 1 milliamp for full-scale deflection. To make this galvanometer into an ammeter reading 200 milliamps full scale, we need to connect a resistance of blank. First, since we're creating an ammeter, we need as little resistance as possible. This way, we'll get as much current flowing through as possible and get an accurate reading. This means from this equation, we want to connect the resistor in parallel, since that will always decrease the total resistance. Next, we draw the circuit and add what information we know. We'll call Rg the resistance of the galvanometer, which is given as 100 ohms, and since we're connecting it in parallel, we'll call Rs the shunt, the resistance of which we'll be solving for. We know that we want 200 milliamps of current to deflect this full scale, so we have 200 milliamps coming in. We also know that 1 milliamp flows through the galvanometer to deflect at full scale, so we can then use the junction rule to find out how much current is left over and going through this last part. 200 minus 1 is 199 milliamps. Next, we know that since these are in parallel, the voltage of the galvanometer and the voltage of the shunt are equal. We also know that voltage equals IR. Therefore, we know that the current of the galvanometer times its resistance is equal to the current of the shunt times its resistance. We can rearrange these to solve for the resistance of the shunt. We can throw in the numbers given to us in the problem statement, and we can solve for the resistance of the shunt, which we find to be 0.5 ohms, and again it's in parallel, so the answer is C.